we going, guys? How's the sound? How's the sound? Heater. All right, guys. We're gonna give a couple of minutes just for a few people to come on. Zaria. It's been a hard 24 hours, man. Like, just been hectic. Yeah, the dog ran away yesterday. It was partially my fault, and then couldn't run the tutorial last night because I was literally walking around near our neighborhood just calling out his name. Yeah, I think if he didn't arrive last night, I don't think I'd be running a tutorial tonight because I'd probably be still outside just screaming out his name. It was pretty hard. Welcome back, Cherry. Welcome back. Lape. Hello. Welcome back. How did it go, Zaria? Was it level 3 calculus or? Thanks, Dotson. But honestly, man, yesterday I would have given anything to get this dog back home. So, yeah, that was good. He's sleeping at the moment. Oh, you guys can't see him. It's alright. I'm sure if there's a cat that comes through, he's gonna go a bit crazy. Got another 20 seconds and then we'll start going through the paper, guys. We're gonna go through this paper, just question 1 today. Yeah, but like a bit low on energy at the moment. Didn't get much sleep as well last night because I had to take him into the emergency vet. That was another story. Right. Yeah, so if you, Zaria, if you do kind of remember any questions, just sketch it out on a piece of paper and just drop it in my email, and I'll kind of get to it if I can. But we might as well get started, guys. It is 8 o'clock and I did say like we want to try and finish question 1. And then what I'll try and do is I'll upload the differentiation paper because I haven't finished editing it. Once I finish editing it, I'll upload it so that you guys can catch up with that as well. So without further ado, let's get started with question 1 here. What I will do is I will actually put down what time I'm going to go through the answer while I just have a chat with you guys on the side. So we're going to go through this at about, what's the time? Yeah, let's go through with 8:03 p.m. all right? So have a go at this question. Yeah, and then we'll actually go through the answer. When is your guys' mocks coming up? Is everybody doing their mocks in week 8 at the moment or a bit earlier? Because I know there was one school that I think did it last week. Week 10. Wow, that is a while away. Yeah, week 7, that sounds like no, we're in week 6 at the moment, so week 8. Yeah, week 8 seems to be like the standard time for mocks. Wow, that's a while away, Harrison. That's pretty long time away. It was funny, right? Like I was reading up some of my old comments because sometimes none of the like I don't get all the comments that gets tagged, So it doesn't, I don't get the notification when some comments are kind of conversations are happening. And I found a comment last year where a kid had joined the night before MCAT live stream, and I basically said, yeah, I'm not going to go through any questions. And I think he kind of messaged in the comments and said that, nah, stuff you, man, I've been waiting for the whole day for this tutorial, and all you're going to tell me is that you're not going to do any questions. I was like, man, come on. There's so many other questions that's there that you could have been working on, but you didn't have to wait for this live stream, right? But year 11s, rookies. Anyway, guys, I am going to start recording these questions on the side as well. So if I kind of go quiet because I'm probably answering the question, I'm just trying to see, hold on. Can I put this? Yes, I can. That's fine. I can put this there. I can get rid of it. Just sorting out my screen here. Yeah, so what I'll do is I'll go through the answer, and then I'll just ask you guys any questions, and then we can just move on to the next one. All right, so recording. Okay, so question 1A, nice, straightforward integration question. I guess this one you've just got to be kind of careful that you've actually got 3 over x there. And a lot of people tend to actually bring the x and put it as power of -1. Remember that whenever you're integrating and you have just x in the denominator, you will have to integrate it to ln. So don't forget that. So in this case, what we've got is x. We've actually got x squared over, so x over 3 first. And because it's raising the power by 1, so it's going to be 2, and then dividing by the new power, which happens to be positive 2. Plus 3 over x just integrates to 3 ln of x. And of course, don't forget the plus c. Now in the answer schedule, it actually says that plus c is not required. You know, and you can actually leave your answer like this. You don't really need to simplify it. But for those fanatics that want clean answers, they probably do this. X squared over 6 plus 3 ln of x plus c. Now this question is worth and achieved, and I'm fairly confident that you wouldn't need to do that 3 times 2 to, like, they wouldn't tag you down for that. So that is question 1A. And do you guys have any questions with this one? Was it fairly straightforward? Can we move on to the next one? Yep, sweet. All right. Okay, so this one I'm gonna go through at 8:08. Give you guys a couple of minutes to try and do this. Now, just be careful with this one. Is sometimes people see dy dx and they start thinking differential equation straight away, but it's not. So yeah, I'll let you guys have a crack at it, and then I'll go through 8:08. I know last kind of session we were kind of having a chat about it, like what do we do for 25k subs? I think the last time I spoke to you guys, we were like, I don't know, was it this group or another group, but what do we do? Do we do like a giveaway? Or, I don't know, I was thinking about talking to some of the level 3s about it, but I can't remember which group I talked to. No, the signed NCEA paper is insane. But I like the merch idea. I talked to my wife about it, and she's like, "Oh, that's a really cool idea," you know. And I reckon if the winner is in Auckland, I'm quite happy to come and drop the T-shirt off. Probably I'd have to get some permission to come and drop it off at class, but that'd be quite hilarious to do something like that. Yeah, so I've got I've got two masks with infinity plus 1. So something like this. This is my old one, but like, oh no, you can't see it. Hang on. There we go. So I got a couple of those, and maybe do a t-shirt. But I was actually thinking about releasing my own line that was going to say something like, I am one off, and then in the back it says infinity plus 1 or something like that. But we'll get to it, right? We'll get to it. Definitely two masks for sure. Like, I mean, I've got to give these two masks. I kind of have like a couple of masks still left over there, brand new ones that I haven't actually touched. So anyway, it's 8:08. Let's go through this next question. Is it a merit question, the second one? Oh no, it's just achieved. All right, so the question 1b, part A, what we've got here is gradient functions being given. As I was saying in the stream before, if sometimes when we see dy dx, we automatically think differential equations. But in fact, in this one, it's just a straightforward integration here. So what we're going to do is we're going to write down dy dx, and we're going to write that x as a positive. Sorry, not positive. We're going to bring it to the numerator with a negative power. All right, so once that's done, now we're integrating both sides, which means when we integrate dy dx, we're going to get y is equal to 8x minus 3, and I've got plus 1, negative 3 plus 1 is going to be my new denominator, plus c. So what I've got here is y is equal to 8x to the power of negative 2 divided by negative 2 plus c. So what I generally have is y is equal to negative 4 x to the power of negative 2 plus c. Now, unfortunately, I need to actually find the equation of the curve if it passes through the point 1, 3. So the first thing is, what do we got? What do we got? Let me just have a quick look here. I've integrated it. If it passes through 1, 3, right. So all it's really asking us to do here is just figure out what the value of c is. And we've got 1 and 3, so we're going to substitute 1 and 3 in this equation. So when we substitute 1 and 3, because our equation is y is equal to negative 4x to the power of negative 2 plus c, I am going to replace x with positive 1 and 3 with y. So I'm going to have 3 is equal to negative 4 to the power of times 1 to the power of negative 2 plus c, and I've got 3 is equal to, now 1 to the power of negative 2 is just 1, so I've got negative 4 plus c, and c is equal to 3 plus 4. So I've got c as 7, and therefore I can say that y is equal to negative 4x to the power of negative 2 plus 7. Now this grade is worth an achieved, and it looks like you need a correct solution with correct integral to get that achieved grade. Right, any questions with that one, guys, before we go to part 2 of this question? Cool, that's one tick there. Okay, so if that's good, let's go to part 2 of this question. So just to give you guys a bit of the equation was y is equal to negative 4x to the power of minus 2 plus 7. Is that the equation? Yeah. All right, so this one I'm going to go through at 8:15. So have a go, guys, with this question. Yeah, have a go at this question, and then we'll go through the answer very shortly. Right, so much it is then. What, do we have like a white t-shirt with black writing or black t-shirt with white writing? White t-shirt gets dirty, man. It's a pain. I think the closest one that I did was like on a blue t-shirt, and that came out quite nice. Yeah, that would be pretty cool. Well, looks like we've got black as a winner here. Black t-shirt with white writing. By the way, guys, this one is a merit question, and it will, you can actually check the answer on the calculator as well, so. Well, that's alright, Infinitum. I did put it up yesterday on Instagram, and then, yeah, then the dog went missing and there was a whole lot of drama. Hey, Drew, welcome, mate. How was class today? Yes, I do teach at a school.
I found a few English language schools near you. The first one is Kaplan International Languages, Auckland at 10 Titoki Street, Parnell, Auckland. The second one is Kaplan Aspect at 10 Titoki Street, Parnell, Auckland.
Hey, Google.
The third one is Kaplan International Languages, Auckland.
Okay, that was a bit strange. Did that actually pick up everything? I talk about sensitive mic, man. I'm like whispering here, and then that little. That's always a good crack up. Right. Anyway, yeah, Dante, I do teach at a. I'm afraid to say the word school because it's like it's listening all the time. Yes. Okay, look, I'm going to go through this question first, and then after that we'll talk about the school in the next little break that we have when we try to figure out the next question. Okay, so for this question, we've got a... Hang on, let me just click record. So for this question, we've got to figure out the area that's enclosed by the curve, right? The x-axis, lines x equal 1 and 2. Now, what you can do, guys, is just do a quick graph on your calculator just to see what the graph actually looks like. So we've got -4 multiplied by x to the power of -2 plus 7. Okay, so it looks kind of like an ugly looking graph anyway, but like what does it actually look like if I zoom out a bit? Okay, so it's one of these weird looking curve things, right? And we're looking between 1 and 2. So it's like somewhere between there and there. So if we were to kind of like sketch this graph real quickly, it's probably going to look something like this, right? So that's your curve right there. And I guess 1 and 2, I mean, like, we kind of need to know. So it could be like 1 and 2 is like that. So without knowing that, so what I'm going to do is I'm just going to exit and I'm going to put another line. Y equals to 1, x equals to 1. So I'm going to put type, and notice how there's x equals to c. So I'm going to put x equals to 1. And you can kind of see that like it is, I'm going to zoom in a bit. There's that line when x equals to 1, and then this other line tends to be the graph. So in that case, going back to our diagram, we can kind of say that this is between 1 and 2. So we kind of need to establish that first, because sometimes you don't know whether the graph area is actually going underneath the x-axis, and if it does, then you need to separate the intervals, right? So we're going to go between 2 and 1. And our equation is negative 4x to the power of negative 2 plus 7. And of course, we're going to put that dx there. All right, the next part is actually integrating this. So we're going to get negative 4x negative 2. We've got plus 1 to the power, negative 2 plus 1 in the denominator, plus 7x. And of course, we don't really need to worry about the c for this because we have a definite integral which is between 2 and 1. So we're going to get negative 4x to the power of negative 1 divided by negative 1 plus 7x between 2 and 1. And I'm just going to write this as 4x to the power of negative 1 plus 7x between 2 and 1. Now, you could be a little bit lazy and just put this in the calculator and get what the answer is. And I'm going to kind of do that anyway. And the reason is, and I want to show you guys this, right? Because what you can do is you could have actually gone into option, go into calc and integral and put in the equation. So we've got negative 4x to the power of negative 2 plus 7. And then our two limits, which happens to be 1 and 2. So when we do this, we get an answer of 5. Now, when I look at the answer schedule, right? Because you could have actually just stopped at the second line because you've integrated it. You've shown that it's between 2 and 1, and you could actually go equals to 5. But I always play the safety one. The safety one is like getting up to this line here. So I'm actually going to write this as 4 times 2 to the power of negative 1 plus 7 times 2 minus 4 times 1 to the power of negative 1 plus 7 times 2. And I would say that we would pretty much get 4 over 2 and 14. So we've got 2 plus 14, take away 4 plus 7. So we've got 16, take away 11 equals to 5. So what you could have done is I probably would have done something like from here to kind of here, just substitute those x's with 2 and 1, and then I would have just written down the answer as 5. But I would always check the answers in the graphics calculator just to see that I'm actually correct there, because the reason is this is a merit question, and it's like you can get a merit fairly easily if you can just integrate, and then you don't, because you can easily make mistakes with the calculator. So that's why I always recommend this method for you guys. Like put it in the calculator, get the answer first, and then make sure you integrate it correctly, and then put the answer at the end as well. So correct solution with correct integral will get you a merit. Correct integral will get you an achieved. So that's getting up to that part is getting achieved. But if you actually get to that part, you really should be getting a merit, because that's pretty much like the penultimate line that you need before you write down the answer anyway. So, just get into the habit of like using the calculator to actually check your answers for these types of questions. Yeah, thank you. I missed that. Sorry, just made that mistake here. That should be 7 times 1. Let's try and change that out. Thanks, Leip. So was that one all good, guys? And we can go to the next question. I think, Amber, I saw your question pop up. I might just need to shift my schedule just for this week. We might miss out level 1 this week, but next week I'll do a double up and just catch up with you guys. I think leading up to MCAT we'll do a little bit more. Any questions with this one, guys, or are we ready to move on to the next question? Cool. All right, let's go to the next question. So with this one, is this an excellence question or a merit question? Okay, it is a merit question, so I'm gonna give you guys about 6 minutes. No, 6 is too long. Let's go 8:26. So who was it? Danson, you are asking me, do I teach at a school? Yes, I do teach at a school. Teach junior college. I teach maths to year 8 and year 9s. That's the maximum I go. I have to say, I think I enjoy the nighttime tutorials because I get to do like a little bit more harder. Well, not harder, but it's like stuff that's like I enjoy. Do I enjoy year 8 maths? Nah, not yet is what I'm gonna say, because yeah, it's just funny, like when I'm trying to teach kids like measurement, when it's like 100 millimeters is 10 centimeters, just like whew. Which school are you at, Danson? Wouldn't mind actually coming and doing like a calculus class just for the hell of it. Liston. Man, Liston. Is that where I think it is? Yeah, I remember Liston. My mom got a teaching job there way back in the day, and she had to travel, like she took like 2 or 3 buses to get to work. It was insane times, man. And then she had to quit after like a month because she just couldn't travel that far from where we lived. This was before she learned how to drive. So guys, remember with kinematics, integrate acceleration to get velocity, integrate velocity to get displacement. So it's just a little hint for you, and then we'll go through the answer in a couple of minutes. Alright guys, we're going to go through this question here. If you need a bit more time, just mute the mic and watch me work through this. Alright guys, so with question C, what we've got here is a classic kinematics question here. So remember that when we have acceleration, velocity and displacement, to go this way we've actually got to integrate, and to go the other way, so displacement to velocity, velocity to acceleration, you've got to differentiate. So with that in mind, we've got our acceleration, so we're going to put that down first. So acceleration of this object is 2 minus sine 2t. Now there's a couple of interesting points that's actually been given to us. We've been given some facts here. When t equals to 0, velocity is 1 meters per second and displacement of 3. So if we're going to write this in kind of formula, I guess, you can actually say v of 0 is equal to 1 and s of 0 is equal to 3. Of course, these things are going to come in quite handy because the question itself is asking what's the displacement of the object at t equals to 5. So the question is actually asking what is s of 5. So we're going to work through one step at a time. We're going to actually integrate acceleration, find out what the velocity is, integrate velocity, find out what the displacement equation is, and then finally we can actually work out what s of 5 is. So going through this, we can actually say v of t is integral of 2 minus sine 2t, which is going to give us 2t. Now negative sine, when you integrate it, you're going to get positive cos. So this is going to become cos 2t. But of course, you've got to divide by the differentiation of whatever that inside that cos function is, which in this case, differentiation of 2t is 2. And we've got to, of course, remember the plus c. So this is what the velocity function is equal to. But we know that velocity v of 0 is equal to 1. So we can actually use that to figure out what the first c value is going to be. So we're going to say, since v of 0 is equal to 1, we can say that 1 is equal to 2 times 0 plus cos of 2t. But of course, t is equal to 0 divided by 2 plus c. So when we do this, now we know that cos of 0 is equal to 1. 2 times 0 is 0, so we're going to get, what is it, cos of 0, well that's 0 plus cos of 0 is 1 over 2 plus c. And because of that, we can actually say c is equal to 1 minus half, therefore c is equal to positive half. So what we've got right now is the velocity function. Velocity function is equal to 2t plus cos 2t over 2 plus 0.5. Now we need to integrate this to find the displacement equation. So we can say that s of t is equal to integral of 2t plus cos 2t over 2 plus 0.5. So we're going to get s of t is equal to 2t. When you integrate it, we're going to get 2t squared divided by 2. Now cos, when you integrate it, you're going to get sine, so we're going to get sine 2t. Now this is the original 2. When I say the original 2, it's actually this one here. But I've got to divide it by the differentiation of whatever the bracket is, which in this case is 2. So I've got to add that extra 2 there. And of course, don't forget that this is also plus 0.5 t. Cool. So we can actually say s of t is equal to t squared plus sine 2t over 4 plus 0.5 t. And of course, don't forget the plus c. We might not call it c, we could call it like another letter because we already used c before. So, I mean, if you want, you can use c1, c2 if it helps. But yeah, I'm just going to use a different letter. Okay, now I need to figure out what the k is. And I know that s of 0 is equal to 3. So because s of 0 is equal to 3, I can actually say 3 is equal to 0 squared plus sine 2 times 0 over 4 plus 0.5 times 0 plus k. So I'm going to get 3 is equal to, this is equal to 0. Sine of 0 is 0. 0.5 times 0 is 0. So I'm going to get k is equal to 3. So I have the equation for s of t, which is equal to t squared plus sine 2t over 4 plus 0.5t plus 3. So now I can actually work out what s of 5 is, because that's what the question is asking me to do. So I've got 5 squared plus sine times 2 times 5 over 4 plus 0.5 times 5 plus 3. All right, so we're just going to punch this in the calculator. So we've got 5 squared plus sine of 10 divided by 4 plus 5 times 0.5 is 2.5 plus 3, and all that gives me 30.36. Okay, so long question here. Definitely a very long question to just get a merit, but unfortunately that's all it's actually worth, because if you guys have a look here, it's, yeah, correct expression for VT gets you an achieved. So your achieved is probably in this line here. That's what you need to do to get an achieved. But for a merit, you need to do all that, pretty much that entire extra bit of work there to actually get a merit. I'm going to leave this question up, guys. So I know that there's always people wanting to know certain parts of it. So I will leave this up just for a couple of, maybe a minute. Like, so if there's any questions on the chat, let me know. Otherwise, I'll kind of put the next question at the bottom there that you guys can actually have a look at. Sorry, Stacey, it is, yes. I'm kind of just catching up on the comments right now. So displacement can go positive or negative. So it's kind of like it's a position from wherever the origin point is. Joshua Lai, I think if you actually make a work to answer video like I do and put it up, I'm sure you're raking the views, man. Kritika, no, you won't get marked down for it. As long as you understand that you've actually got a constant there, then you should be okay. Charlotte, I think this week, I can't remember my schedule. Hang on, give me a second. I put it up on Instagram because I knew I was gonna forget. Give us a second. He was there and it's gone. There we go. So Monday level 3, and then Wednesday and Thursday level 3, going through question 2 and question 3. No worries. So any other questions, guys, before we go to the final question for the night, which is an excellence question, but from Auckland. What time will the stream be on? Jung, it'll always be at 8 o'clock, man. Or person. Still getting used to the pronoun thingy. Yeah, so all tutorials will be at 8 p.m. until if I'm really tired, I'll probably start it a bit early, like 7:45, but otherwise it's at 8 o'clock. All right, shall we go to the next question, guys, or how do we feel? All right. $30.54. Nathan, is that for the previous question or? Huh. Wonder how you got 30.54. And my dog's about to go. Hang on. Come on, boy. Go get that cat. Nathan, I'm gonna say check your calculator mode just to see that if it's in radians and not in degrees. Come on, you can go. I know you're tired. Go back at that cat. He's been very groggy today, so guys, I will go through this answer at 8:45. Sorry, I'm just having a look at the previous question. Did you do cos 2t over 2 over 2? You will need to do cos t. It won't be cos, it'll be, Jong, it'll be, it will be sine, because when you integrate cos, you're going to get sine. Nathan, majority of your questions in calculus will be in radians, like majority of them. So guys, if you are struggling to kind of give you a starting, like to figure out a starting point for this question, I will give you this as a little hint. Just this part right here, you can actually have it as, that's what it actually means, that particular line. So if you haven't actually if you're struggling to answer this question, like that's your starting point as a hint, and have a go, and then I'll kind of go through the answer at 8:45, because you guys will need a little bit of time to get through this particular question. Come here. If you differentiate and integrate sine, what do you get? Well, if you differentiate sine, you will get cos. If you integrate sine, you will get negative cos. You're not going to get the same thing, Stacy. That's one of those, like, it's a misconception. Like, people think that, oh, because I differentiate sine, I'll get cos. But it doesn't work in reverse like that. But yeah, Eggman is right, Stacy. You will get a formula sheet which you will have access to at all exams, which will have a table of all of your whatever you can differentiate to and whatever you can integrate to. Let me just check if they have an integration one or not. I thought formula sheet. All right, so where are we at? Stacy, this is what you get given in the exam paper, this particular formula sheet. So you can kind of have a look at that when you actually differentiate sine, you actually get cos x. But then when you differentiate minus sine x, you will get positive cos x. So if you integrate sine x, then you would actually get negative cos x. Yeah, pretty much what Downson is talking about. You can actually just use the reverse from that particular table. I forgot that they don't actually have an integration because it's been such a long time since I look at that formula sheet really. So it's alright, dancing. It's my way of giving back, man. It's all I can do. Go on. Go on. You go get that cat. There he goes. Always has to make an appearance, right? He has to make an appearance in a live stream, just barking at cats. He hasn't barked yet though. Nathan, I'm like, normally I get so annoyed with him when he's barking out, but yeah, after yesterday's ordeal, man, I'm like, just do what you want, dog. Just do what you want. Bark at the cat. Honestly, I was completely just broken yesterday, man. I was broken. Was that... It's not as loud as what he used to be. Cherry, I would love to lift him up, but he's still a bit he's a bit sore from yesterday. I'll see if he comes near me, then I'll pick him up, but he's just been sleeping most of the time. Anyway, let's go through this question first, and then after that we can do a dog reveal. Okay, so we've got our final question for question 1, which generally tends to be a nice, well, not a nice, but it's just an excellence question. So what we've got here is a kind of like a differential equation, I guess. Water tank developed a leak. 6 hours after the tank started the leak, volume is 400. So first kind of little thing that we're going to write down is that T is equal to 6. Volume is equal to 400. Next it says when 10 hours 256, so T is equal to 10, volume is equal to 256. Now the fourth bullet point where it says the rate at which the water leaks out. Now that first part right there, this part, the rate at which the water leaks out, we can actually call that dV dt because the volume is changing over time, and that's what that rate at which the water leaks out, rate at which the volume is changing. Okay, and it actually says is proportional to the square root of the volume. So we know that we're going to get square root of volume, but it's proportional, which means it's some kind of constant, and we don't know what that constant is, and so that's what we're going to actually put down here. So that proportional part is where that K comes in, and the square root of the volume is where the square root of V comes from. So in saying that, we have got our differential equation, dV dt is equal to K square root of V. Now this part, what we'll need to do is we can't just kind of go, oh yeah, we're going to integrate v as to the power of half, and it doesn't work like that, because if you think about it, in the denominator you've actually got t, which means, you know, when you integrate this, you're going to get like k square root of vt, which doesn't really make sense. So that's why we've got to bring in all the elements of v to one side and dt to the other side. So this will actually be looking like this: dv over square root of v is equal to k dt. So if that's the case, we can kind of say that dv over square root of v could be written like this: 1 over x to, sorry, not x, v to the power of 0.5 dv is integral of k dt. So this is what we are going to try and do here. I'm going to try and see if I can squeeze a little bit more out here. So we're going to rewrite this as v to the power of negative 0.5 dv. And k dt, well, if I integrate k, I'm going to get kt plus c. Don't forget the plus c part. I'll kind of carry on here. Now, integral of v to the power of negative 0.5. So we've got v to the power of negative 0.5. We're going to go plus 1 to the power divided by the new power, which is that, which is all equal to kt plus c. So we're going to get v to the power of 0.5 divided by 0.5 is equal to kt plus c. Now 1 over 0.5 could be written as 2 root v equals kt plus c. So with that in mind, I kind of forgot one important part, right? The fifth bullet point, which says how much water was in the tank at the start of it when it started to leak. So we're looking for, when t is equal to 0, what was the volume there. Now what we've got here is we've actually got a set of simultaneous equations, and it's a good little trick for you guys, is that, you know, when you have like 2 bits of information like this, you know you're going to be working with simultaneous equations. So with that in mind, my equation is 2 square root of v equals kt plus c. My first point is 6 400, because t equals to 6 and v is 400. So I'm going to work that out. So I've got 2 root 400 equals k times 6 plus c. Now root 400 is 20, so 20 times 2 is 40. 40 equals 6k plus c. My second one is 10 to 56. So I've got 2 times square root of 256 equals k times 10 plus c. 256 square root is 16. 16 times 2 is 32 equals 10k plus c. Now, I've got these 2 simultaneous equations. If you want to do this the long way, you could do it the long way. You could put it in the, you know, put them top of each other, subtract, and you can do all of that if you want to. But again, for me, it's all about efficiency, right? Like in these kind of things, when I see a simultaneous equation at level 3, I'm not going to be sitting there wasting my time trying to do it manually. If you have a calculator, then just use that straight away. So I'm going to put 6k at 6 and 1. So I'm going to put 6, 1, and the number by itself at the end, which is 40. Then I've got 10, 1, and 32. Just going to solve that. So this is actually telling me that k is equal to -2 and c is equal to 52. So what I've got here is 2 times square root of v equals -2t plus 52. So now I want to know when t is equal to 0 what the volume is. So because t is equal to 0, I am trying to figure out what the volume is. I've got 2 root v equals -2 times 0 plus 52. Then I've got 2 square root of v is equal to 52. Square root of v is equal to 52 divided by 2. Square root of v is equal to 26. And v is equal to 26 squared, which gives me 676. So what do we got for grades wise? Grades wise, E8. Right, correct solution gets you an excellence, and this is an excellence question that's actually worth 8 points. Correct general solution to DE plus C not required, so that's an achieved, which would be correct general solution, so you'd have to probably get somewhere here to get to achieved. Merit is getting up to this part here. So yeah, that is pretty much this question here. Yes, sorry Ted, I hope that the highlighted part there kind of makes sense as to how the equation actually came up. Yep, thank you Nani and Dunstan. So how did I know that I was working with a simultaneous equation again? Well, I've actually got two unknowns and they've given me 2 points. I'm particularly looking at here. So if you look at this, this is a really good clue right here that's going to tell you that you're going to be doing simultaneous equation, because they've given you like a point and a value, a point and a value. Generally they tend to do that if they want you to do simultaneous equations. And also when you came to the original equation, if you look at the original kind of equation that I came up with, I've actually got 4 things that are unknown. Like I've got V, I've got T, and then I've got to figure out what K and C is. And I think using these 2 points, what I can then do is I can get rid of V and T, then I can actually use what K and then I can figure out what K and C is. So that's how I knew that I was kind of working with simultaneous equations. So Eggman, generally when you're talking about proportional, you don't know what proportion it is. So that's why you use the letter K. So we don't know if it's like, if the proportion is like, sometimes they say like inversely proportional, but it doesn't really matter, because when you, even with that, you can actually still kind of use the K, and you should be kind of okay with it. On the calculator, Jiong, what I do is you click on menu, go into equation, and under equation you've got, you'll come to this kind of menu here, simultaneous, polynomial, and solver. You click on simultaneous, number of unknowns is 2, and you would have seen this. I've just rewritten the equation because I know I put it as 40 equals 6k plus c. So I've kind of went this column here, so whatever the a value is as k, and then whatever the b value here as the c value, and I think could be a bit of a confusion, but the letter c here, actually I've used it as a constant. So whatever my numbers were, that's the 40 and 32, that always goes towards the end. And the variables, which is k and c, comes up here. So you can kind of see x variable, y variable, and then the number by itself. Hope that makes sense, Jiang. Otherwise, have a look at my playlist, graphics calculator tips. There's a simultaneous equation graphics calculator video out there for you to have a look at. Right guys, apart from that, any other questions? Because that's pretty much us for the night today. I will catch up with you guys for question 2 on Wednesday, and then we'll finish off question 3 on Thursday. That's alright, King. Just give it like about 2 minutes, 2 to 3 minutes, and then when I stop the stream, it should be back up. It should be uploaded on my channel. So once I stop it, give it like 5 minutes, I think. It should be ready to go, and then you can rewatch it. Yeah, it's weird, right? Because I think like it's when I'm explaining it, like it takes us an hour, but I think what you're expected to do is you're expected to do this question in like 20 minutes because three questions in an hour is what you're expected to do for these papers. No worries, guys. I will, as always, I'll hang around for a couple of minutes just to have a chat. But that's us for today, and get some rest. And I'll see you guys again on what is it? Wednesday. Wednesday. And of course, don't forget, like we've got to do our what do you call it? 25k giveaway soon, very much. No worries, Kritika. You have a good night. I'm quite excited. I mean, what if I just realized I have to actually oh, Cherry, before you go, where is he? He hasn't actually come back yet. I think he's still outside. I'll see if I can find a picture of him, Cherry. Hold on. Good old Watson. See you, Nathan. No worries, Lika. You're welcome. There you go. This is Watson. The little munchkin that ran yesterday and it just got me worried. Man, I didn't realize I can actually see my reflection on his eye. See you, Sam. I was a broken man yesterday, Cherry. I was a broken man when I couldn't find him at home. Just glad he's back. Just glad. In fact, speaking of glad, he's actually hasn't returned out from outside yet. Might go check up on him. That's us done. Done. Alright guys, thank you so much. I will catch you on Wednesday. I need to get some shut-eye. Have a good night, and yeah. Wednesday. We'll catch up on Wednesday. Bye, Cherry. Bye, guys.